Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have Dr. Ching-Yung Lin. He's the CEO of a company called Graphen, Graphen.AI, and they're studying the COVID-19 virus. They're studying how it has been mutating and changing, and we're going to get into this. It's obviously very topical, very important for what's going on to understand. So, Dr. Lin, thank you for coming. How are you doing today?
I'm good. I'm very good. Thank you.
Okay. Tell me about Graphen. What is the premise of the company?
So Graphen, that we are actually an AI company that we build our platform, and then we build it for finance and medical solutions.
So in regards to the coronavirus, how did you first learn about it, and how did you decide to work on it?
So our company, we actually has been specialized in a way that we try to do the graph analysis. So that is actually network analysis. So we actually have been working on the work like how do we analyze the terrorist network, or how do we analyze the anti-money laundering to see how people they do the money laundering around the world, or if there's some kind of a default for some companies, how do they propagate this kind of default disease through many companies. So in a sense that we actually has been working on something related to the virus propagation, but not exactly the same. So when we actually, in around, I think February, the end of February, we feel that this virus issue is becoming worse and worse. Then we start to think about, is there anything particular we can contribute to the world or to the people to let them understand what's going on the propagation. And we try to search the web, but we actually cannot see other people who are really doing this work to kind of find out and review propagation. So we decided that it may be a good chance for us to jump in to contribute to the worldwide people to help to resolve this mystery.
Okay, so how have you decided to determine how the virus is spreading? What are you doing specifically?
So I think around the time we actually found out that the worldwide research lab, they actually have been start collaborating by contributing the whole gene sequence of the viruses they found. So they include about more than like 30 countries, and I think about at that time was around near 200 viruses were already being sequenced. So most of these labs, they just submit their sequence to organization, and then they share that for each other. So then I try to apply the membership to get in to look at that, and then they give me the membership to look at to download the result. So so from the gene sequencing, then we actually has a good opportunity exactly finding out how the propagation goes, because that when the virus they propagate, it may mutate. So when it mutate, then you can actually figure out who is whose parent and which virus is whose son, and even grandson, something like that. So then this is a way, if we analyze in this way, we can find out exactly what happened on this propagation and the mutation.
Yeah, I didn't. I thought that it was the virus was sequenced once and then not again. But you're saying that different countries are sequencing the virus and they're finding mutations of the original one, and you're using that to make a map of how the virus is changing in the different countries?
Yes, because that the mutation is a very important indication about how it changes, like who changes to whom. So as long as we can have these mutations points changes, then we are able to understand what's going on. So that is a very critical
Okay. So what are you noticing so far about the coronavirus? How is it changing? Are there any patterns?
I think the first thing I found out is about how many changes it actually happened. I was a little bit surprised at the very beginning about the number of the changes. So for example, at this moment, there are about 1,700 viruses that are sequenced. So those are actually the number of the viruses being doing the gene sequencing by the labs. Okay. And then among these 1,700 viruses already sequenced, there are about 900 different types of the viruses right now today.
Wow. How different are they? Do they appear to have like one mutation or many mutations? And are you seeing branches and trees and families of variation? Like what does the variation look like?
Can you hear me? So the variation actually, can, right now there are about, I think some of the bigger ones probably have about 15 points that are mutated, that are changed. Okay. And in terms of how these changes, they will change the way the virus function. There's no kind of there's nothing is already known about which change can cause what.
Well, can you tell by the now that the virus has been sequenced, can you tell what the genes in the virus can do? And then can you look at mutations and see if it has certain mutations, how that will affect its genes and its abilities?
So at this moment, it is not known for the human being about if you have a particular change, then what kind of a new function the virus can do. So this is not something scientists already know. So scientists usually at this moment know about if you change in which section in a gene, it may affect the capability in some way. So for example, that right now we do know about some sections in this virus that are functions for is a spike. So spike are the one that try to kind of hang on to the human cell. Okay.
Right.
Or there are some virus is a very cold capability. And something is very particular is that we scientists actually right now kind of understand that there are a few sections that are more likely to be the place that the virus can be widely propagated. So for example, some of the researches actually show a section in the kind of the about 1/3 position of this virus genome. Mm-hmm. That section may help the virus to be easily to duplicate themselves, and they may be more easily to make the virus look more like a human cell. So at the very beginning, when the virus they enter the human body, our immune system will not be able to recognize it is actually a virus, but
really?
It can be just mistaken that
you're seeing changes in the capsid surface proteins and then in the spike proteins that it uses to enter cells as well?
It is not actually on the surface of the spike, because it's more like the spike or surface are the one try to cling to the cell. Okay.
Right.
So it's more like the capability portion. But in this virus, that there is a possibility is other parts that are responsible for duplication, like for duplicate, because virus they actually enter our body, then they try to duplicate and they try to grow very quickly inside our body. Okay, so some part of the gene are responsible for this replication to duplicate itself to keep growing. Mm-hmm. And there is a theory is that some portion of this virus gene they are responsible for this duplication. And in the previous study in SARS, actually it was found out that if you try to change one point in that particular portion of the virus, then its duplication capability can reduce to only 10%.
Okay.
Of what SARS can.
You know what's interesting? What do you think are the trade-offs So the virus is adapting and changing, but if it gets better at hiding from the immune system, does that mean that it loses some other ability? I would think that there are many trade-offs as it changes.
I'm afraid not necessarily, because that if so, for example, like what I just mentioned, the SARS situation, if you change one point, then the way it duplicates itself can change a lot.
Yeah.
So similarly, it may be possible just a few points changes that actually create this coronavirus, the COVID-19, was only just a few changes that actually created this capability today to be able to be highly propagated. And lately, we actually also hear some of the things about some virus, that are popular here in New York. People may lose their taste at the very beginning.
Okay.
But we didn't hear this kind of theory in the original viruses in Asia. I think
That's right.
Asia, we didn't hear that. Right. And at some point, I think in February, we also heard some viruses in Beijing is quite strong, not only attack the lung, but also attack neural systems, other part of our neural.
Can you, when you look at the virus in various countries, are all the viruses evolving along the same path, or are they evolving very differently depending on the country?
We actually have been seeing that viruses right now are developing country by their own.
Okay, so but as the virus progresses in a given country, like in Italy, are you observing how the virus is changing? And then in the US and then in China, are all the viruses in these countries changing in the same way, or they're all changing differently?
Different.
Are they all becoming worse or becoming better? Like, how are they changing? Are they all just, do you think they're randomly changing, or they're all becoming a certain way?
The change in the mutation is random.
Doesn't seem like it. But do you think, okay, so the end goal is the virus, as it mutates, do you think it's becoming more virulent or less? Like, how is it changing if you look at it in the various countries? What are some of the ways that it's changing that are common?
So I think the only thing common is that it keeps changing a lot, and then each country grow by their own. And so what? 2 months ago, right now is different from 2 months ago when it was in Asia. In Asia, we actually saw the changes that are kind of interchangeable with each other. At that time, they are kind of the change in the same way. But right now, it's kind of different countries that are grow differently. Like Netherlands virus is different from what we see in England. It's different from what we see in Italy or Germany. They are all different right now. And in US, that Washington also grow by its own, Washington State. And the Washington State virus actually propagated to Minnesota and to other places in US. So, and they are all different. In these places are all different. So we actually have been seeing this kind of independent growth by each places. So the problem is that these changes that are all random, random mutation. Sometimes it gets better, that the virus loses ability, but sometimes it gets worse. So there is no definite directions where you will go to.
What about the climate in the different countries? Do you see that? Are there any correlations? In more colder countries, is the virus acting one way, and in warmer areas different? Do you see any correlation between change and conditions?
I think at this moment, I do see that there are a lot of in Europe and also I think in Washington. So it seems to be that the temperature in the colder weather temperature, there are bigger hit. I didn't see a lot of the changes in the warm countries like Singapore, Malaysia. There are not a lot of. So there are actually coronavirus that there are some portion of things that are actually temperature sensitive. So temperature can affect how it grows and how it mutates. It is a factor.
What about do you have a scorecard for the virus? If you put on virulence spreadability, time till symptoms develop, severity of the sickness. If you gave the virus a scorecard and you looked at it depending on the countries it's in, maybe then you could correlate that with the mutations versus its behavior, its phenotype,
Right. I think right now that we don't have enough patient data to come out with very good scorecard about which mutation will create what kind of symptoms, something like that. We can find out some of the mutations that are quite strong to be propagated. Like we actually saw the one that are propagated in Europe that are actually quite capable on propagating. Okay. So it started from one. That one was first found in South Germany, and then later on, that virus was not found for near a month. But actually, within the month, there are a lot of mutations or propagations maybe underway. And that one, then it come out with a lot of the virus in Italy and other places, and then then they change it to Netherlands, and then change it to England. So it has been creating several hundreds of the children based on the one found in that January. So we can find some of them are actually more capable to propagate than the others. We actually also suspect the fourth one that has been quite propagating broadly in Wuhan. That one may not the original one. I mean, it can be possibly being something else, and then it mutate to have one mutation, and then it become blowout. So we do see this kind of, some of them seems to have this trend, have a better chance to propagate than the others.
Okay, so you said that in warmer climates the virus mutates less, in colder it mutates more, and then do you see it propagates more in cold climates or in warm climates? Like under what conditions does it propagate more? Does it propagate more at first and less later on? Like what do you see there?
Right now in warm countries, I think we don't know exactly it's because of the weather or because they didn't test that much. But we do see fewer of these viruses in the warm countries. Very warm countries. Usually we don't see them much. And you can see a lot of the serious places are all in this colder weather country. You do see a lot in Europe here, like here we are in New York or in Washington. We are all more serious than the other places. That's what we saw. So those are some patterns we do see right now.
What about I'm in Austin, Texas, and it rained here a lot recently. And I wondered if the rain would wash virus off of surfaces and wash it out of the air and reduce, the ability for it to spread. Any thoughts there on climate? If there's rain, like a rainy season going on anywhere or a lot of rain?
From understanding so far is that this virus, there is its capability depend on like a temperature. So temperature is one factor, but the humidity, I haven't seen it as a major factor. If you think about Washington, actually, Washington State is quite a lot of rain in winter time, and it doesn't stop. The virus doesn't stop in Washington. Actually, propagate a lot. So maybe Austin has a running coming out, but we don't know how helpful the run is. A lot of the situation, it might be from some kind of human to human contact. So it depends on how close each person is, and that may be a major factor rather than the one heavily in the air. So although there are some research saying this can be airborne, but it may not be that decisive factor.
So where do you see that the virus has undergone the most mutations, and what does that seem to tell you? Like, is it cold climates? Is it a particular if it's been in a certain place for a long period of time, does it mutate more? Like, where are the most mutated forms right now?
So the most mutated form right now they are mostly in Europe. So in Europe, that mutate a lot. A lot of reason is not because of the mutate in the environment, but it's because it has been going through so many people. So virus, the major mutation is actually in our body. So in our body, then they try to duplicate. And then when you try to duplicate, there's a copy and a paste. So when they copy and paste, sometimes it goes wrong. So that is actually the major place that it will mutate. So the more people who got infected by this virus, then the more likely get the mutation.
I see what you mean. So in the U.S., there's maybe 70,000, but in all of Europe, there's, I guess, maybe a couple 100,000. So there's more mutations.
Yes, the more people infected and the longer time it is being propagated, then the more mutations it will create. So that's why that the mutation number actually kind of a good estimate about how many were already infected and about how long it was already being propagated. So it actually is kind of correlated to the mutation points you can calculate. So it's actually a very good indicator about how long these viruses are really already being in one place.
What about over time? Do the mutations seem to happen at an even pace? Or do you see that they happen a lot in the beginning and then they slow down? Any data there?
It actually accelerates. We actually see the mutation speed become faster and faster. Is it because more and more people are infected? So there actually is a lot of danger. So this type of virus is not, it is not something like, okay, if I just keep it growing, most of my population got infected and they were immune to this and then you are gone. This is not true. This type of virus, actually, if more and more people get infected, you can create more and more mutation. And the more mutation, it can have a different capability. It can also possibly cause machine to be useless. So your machine, sometimes you target on something, but if you change too much, then your machine can be not useful. So that's why that the virus, this coronavirus, COVID-19, need to be contained. It cannot be just keep growing. Keep growing will cause this type of issue that can have a even bigger problem to human, to the mankind. So that is actually important. We have been seeing the mutation speed is faster in the last month.
Is it faster because it's faster, or is it faster because there are more chances for it to mutate because it's in more people?
It's faster because of more people.
Okay, I see what you mean. It's more chances, right?
Yes,
every time it infects somebody, it has a chance to mutate. Okay, I got you.
Correct.
So what are you hoping to figure out with your analyses?
I think the most important one is to try to figure out which mutations can cause what problem, and then try to point out if some mutation may already impact the major functions of this virus, then we can have some warning signals to the world to understand that there are some serious things coming out. Or another thing, like if we observe a place, there's a lot of the mutation already happened, but in that place, there has been very few reported cases. Then that must mean that a lot of people are already infected, but the government didn't do announce inspection, so you don't have a much case, but the mutation number actually can tell you that there are actually a lot of huge propagation is already underway. So you better speed up your inspection to contain, to understand who got infected. Otherwise, these people, they just walk around. Because something special for this virus is that it can affect people it can propagate even before you see symptoms. Part of the reason I think was why I said at the very beginning, it can disguise itself to be similar to your cell. So your immune system doesn't attack it. You don't have a symptom yet, but it's already there, so it can propagate. So I think that these are some of the signals that if we see that, then we can figure it out, then it can be important for the people. I mean, in each region or each country.
Are there parts of it's an RNA virus, right? The coronavirus?
Yes, it's RNA, yes.
Are there parts of its sequence that are not mutating? Does it seem like there are preferential areas that are mutating more than others?
No. At this moment, we are seeing the mutation points seems to be random, that it can happen in any point in this about 30,000 points, and the change seems to be just totally random. So we didn't see that which part has a better change than the others. We haven't seen that yet. We are seeing a quite uniform changing pattern all the positions. So that's why those are all possible.
You know what would be interesting too is if you're able to get if places are able to characterize the antibodies from survivors of it, and if you map those out, against the mutation map and see how our bodies are responding to the mutations, it would be interesting to look at that too, I think.
Right. And so in some places, actually, people are using the antibody test how many antibodies of this virus happen in our blood, and then to use that to be a measurement to see whether you actually get this coronavirus or you had that before. Actually, that is one thing that can be used for testing to go by the history. So right now, at this moment, the most of tests, I think the only recognized test actually right now is to use the real checking on the genome of the virus. I mean, in the potential patients. But in some places, you actually can use this one antibody to check that. And there are also some reports saying some people has the antibody, but later on he may get infected again. We don't know whether that was because the antibody is actually only good for the original virus, but not for some new viruses happen. There's too many mutations, then your antibody lose the function. We don't know that may be true or not, but
right. When you get the sequences, are these sequences from virus cultured from people? Like, how do you get the sequences? Where do they come from? When are they done?
They actually were collected from people. Those were all the confirmed cases in the worldwide lab. Then they sequenced that, and then they sent to the common organizations to share. So those are not on the culture, but they actually sequence that. Usually they need to grow that a little bit to get enough amount to actually sequence that. So there are something need to be done, but those are all from the patient.
Are you getting the case history of those patients too, so you could coordinate the sequence with the case history?
We actually so the cases that are from worldwide lab, usually they have their ID, and from their ID, sometimes you can guess who they are from the news report. So they are clearly like for example, Washington, you have a Washington 1, Washington 2, and you have a date on that. And then you also have the patient's gender, male, female, how many years old. Not every virus is patient exact information, but a lot of them, like 70% of them, you have the collection date, you have the gender, you have the age, and sometimes they actually also have information about this is from the cruise, from the Diamond Princess cruise, for example, or the Grand Princess cruise.
Right.
Right. Or sometimes some people will have some comment about where it was, like a little bit more information sometimes. And we also
they should if they really want to study this, they should have all the data and the case outcome for every sequence too, because then you could correlate, these people had these mutations and they all recovered, or these people had these mutations and, triple the number of them died. That would make you, you'd be able to figure out based on the mutations what the effects are of the virus in some cases. So it sounds like you
True.
need all that data, you know?
True. We do see that, like in SARS 17 years ago, after that, many papers try to study about how they may affect, what kind of effect they can cause. And at this moment, I think that things are happening so quick, right? For the common data set, what we can see are something like, I think most of them are like hospitalized, or some of them already say they pass away. There are very few that say they are discharged. Okay, so I think that that may be the problem is that if you are really hospitalized, and for example, I saw some report from New York governor this morning that if you hospitalized for this COVID-19, the time you need in the hospital, maybe in ICU, it can take 20 to 30 days. So therefore, a lot of the patients, maybe they are still in hospital. So it's why a lot of the cases what we saw is just a hospitalized if they are being some kind of the note on the current status. I think it actually takes more time to tell on that part, and actually need more. Yeah, I think in each country probably has more data of that patient can be able to further study about which mutation caused what.
Are you making your data available, your map of the mutations and everything, or are you sharing this back out?
So for on our website, the Graphen COVID monitoring website, actually we kind of sharing the mutation of each virus, and also their location and the gender and the age information. We actually put it there so people can study the evolution tree, and they can search for each country, or they can search based on the date, like what's going on before this date or after this date. They can even see the video animation about how it changed every day, how it becomes worse and worse, for example. So those are all the real data, the true data, and the updated every day to make sure the data is up to date.
Okay. Well, I encourage you, if you can, to try to get the patient data for all the samples you have, because then you'll have a very complete database, and maybe include temperature data and any other data you think is relevant, because that would be a huge resource for everyone going forward. I know you've done a lot already, but anything to do to make the data more complete would give a really good understanding of this that we probably don't have of any other virus like this.
Right. I think you actually raised a very good point, and it will be on our wish list to try to see whether we can contact the important labs to gather more information and then to correlate. I think this type of the very big data study it can be very useful and needed for the human beings worldwide to fight this COVID-19 virus. So I think you have a very good suggestion, and we will do our best try to gather more information.
Okay. Well, very good. What's the best way for people to find you? You said you have should they go to Graphen.AI, and then is there a link to look at the coronavirus sequences, the map of them?
Yes, because all the sequences are there. So it's www.graphen.ai/covid.html. Then you can go to our webpage to see all these real sequencing data from worldwide up to date today. So you can see that. And if you need any information, you can contact us at info@graphen.ai, and then we will answer your email, or you can just follow our Twitter, LinkedIn, or Facebook accounts that we also have information there.
All right, very good. And I'd encourage all listeners, if you have any ability to help Graphen and to get more data to them, whether it's a sequence or a patient outcome or whatever it is, to do so, because they're doing a really important thing that'll be very beneficial to our understanding of what's going on. So I thank you, Dr. Lin. It's a good thing you guys are doing. And again, all listeners, if you can help at all, you should. So thank you for being here.
Okay, thank you very much, Richard. It's our pleasure, and I hope we can also work together to fight this COVID-19, this very important issue for everybody right now.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.